Yes, good evening, my dear kids. Hope I'm audible.
Your voice is very feeble.
Sorry, voice is very feeble, you mean?
Yes, sir.
Is it?
Yes, sir.
Oh my God. Voice is very feeble. Okay, I'll check. Is it fine now?
Yes, sir.
Is it fine now?
Yes, sir.
Okay. Or still, so there is scope for improvement in the volume.
Yes, sir. I don't able to speak more loud.
Still, it can be improved, you mean, right?
Yes, sir.
Oh. I don't think I have directly connected. Only here is the possibility. Please check if I increase my volume further, there may be small noise will get associated. Is it okay now?
Yes, sir. It's fine.
It must have improved now, but problem is slightly noise may be added. Am I right? Yes? Is it fine now? Voice is fine. Please confirm me.
Yes, sir. Yes, sir. Fine.
Fine. Okay, fine. So in our last class, what we have seen, I remember we have done something like series and parallel combination of resistors. You also directed me there is some ammeter, voltmeter, etc. in the as per textbook circuit. We also updated accordingly. Am I right? Please remember. Please check that on your notebook.
Yes,
Please,
sir.
please check that on your
Yes,
notebook.
sir.
Yes. Non-iron Srinivasan. This is class for small kids, 10th standard kids, not for you, Narayanan. Okay, fine. See here, some senior students have joined, so I'm telling them. Okay, fine. Okay, Kana. Now series, parallel. Cholukana, series. One, under what is the condition for the resistors are to be said to be connected in series? What is the condition, Kana? Cholunga, last class we discussed pannumal, yarav solunga pakkalam. What is the condition?
Sir, and it flows through all resistors.
Sorry?
Sir, and it flows through all the resistors.
Yes, same current flows through all the resistors. When same current flows through all the resistors, they are said to be in series connection. When same potential difference exists across all the resistors, it is said to be in parallel. It is said to be in parallel. சரியா? அப்போ series எப்படி இருக்கும் அப்படினு கண்டா எப்படி இருக்கும்? R1, R2, R3. Now, under all circumstances, the same current has to flow. But when the resistors are connected like this, R1, R2, R3. Now connect it to a battery. Now these resistors are said to be connected in parallel because if you connect a voltmeter here, you will see that the same voltage is measured across all the resistors. Suppose it is 5 volt, 5 volt, 5 volt, 5 volt. Even the battery is 5 volt suppose. In the case, same current but potential may be different. Inga potential evlo kanna irukum appadina I R1 is the potential V1. Inga evlo potential I R2 is the potential. It goes like that. So ultimately last class nama enna pannom idella senji finally we arrived at a formula. I hope you remember. What's the formula for that? R equal to R1 plus R2 plus here 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 is the resistance. Have we derived it? Please check it. Or sami derive panama vitutuma check pannu. Have we derived this formula in our class? Last class, please check kanna.
Yes, sir.
We have done it. Excellent. So today.
Sir, I have a doubt.
Yes.
Sir, will they ask to derive this? If they ask the differentiation, sir, will they ask to derive? Will they have to derive this?
Of
or
course.
can we just directly write it?
No, I think உங்களோட கேஸில் I think as per your no derivation is required, but however in our discussion last class I think we derived it, am I right?
Sir, we cancelled the common ones like that.
Yes, that's enough, you are right, Rishi, you are right. Okay, whatever we have done on our notebook, that's enough. Is it okay, Kanna?
Yes, sir.
Okay, so today we are in a position to move to numericals based on this. Adhan nik paaka porom, fully numericals based on this. Polama, I think it's right time we can go. Come on, two resistors, 20 ohm, 80 ohm. R1 equal to 20 ohm, R2 is equal to 80 ohm, are connected in series to a battery of, say 10 volt. Now the question is, what is potential difference across the first resistor is the question mark. What is potential difference across the second resistor is the question mark. Chalo pakkalam, what is V1, what is V2? Come on. What is V1, what is V2? Come on. I hope some of you might have already done. What is current through the circuit? Another idea cholkan. What is current? Total potential by total resistance. What is the total resistance of the circuit?
100 ohms.
100. R1 plus R2. So it is 10 by 100 comes out to be 0.1 ampere is the current. Whether the same current flowing through every part of the circuit, of course the same current flows through every part of the circuit, of course it is yes, same current. Now what is potential difference here? What is potential difference in the across the first resistor? Yes, you are right, V is equal to IR. So at this point V1 equal to I into R1. I is 0.1
2 volts.
into R20, 2 volt. Similarly here V2 is equal to I into R2, same current, 0.1 times 80, which is nothing but 8 volt. So clearly you apply 10 volt, that is being shared by 2 volt plus 8 volt, 2 plus 8, what is total? 10 volt. So 10 volt is being shared. Now what is current in the circuit? 0.1 ampere. What's the total resistance of the circuit? R1 plus R2, 20 plus 80, that's what is 100 ohm. Is it right, Kanna? Is it right to begin with? Lesson ஆரம்பிக்கிறதுக்கு போதுமா? I think it's fine.
Yes, sir.
Yes, copy it. Now I'll give you example in parallel. Now I'll give example in parallel. முடிச்சிங்களா நான் parallel போயிடுறேன். I'll take you to parallel resistors. I will take you to parallel resistors.
That's it.
Done.
Oh, 1 second.
Completed, sir.
Now I want to take a parallel combination of resistors. This is a parallel combination of resistor. R1 equal to 30 ohm, R2 is equal to 6 ohm, this is 50 volt, right? This is current I1, this is current I2, this is current I. Now the question is, what is I1, what is I2, and what is I is the question. Because you know potential difference across 30 ohm is 50 volt, potential difference across 6 ohm is also 50 volt, because potential difference is supposed to be same in parallel combination. Already you know that. Yeah, there is no meaning in asking what is the potential difference, right? அப்போ நம்ம என்ன பார்க்குறோம்? Current. We just look at, try to calculate current. யாராவது ஐடியா சொல்லுங்க. Come on.
Resistance is equal to 5 ohm.
Sorry, kanna.
Net resistance is equal to 5 ohm.
Excellent. R parallel is equal to 1 by 30 plus 1 by 6. You are right. So by solving this, you get resistance in parallel equal to simply 5 ohm. Do you get? Please check. Of course, I did not ask for it. However, what's I1? What's I1? How much voltage this fellow gets? Come on, rather than help pannunga. How much voltage this fellow gets? R1, how much voltage he gets? The 50 volt. Excellent. 50 volt by what's the value of R1? 30 ohm. So 5 by 3 ampere. Then I2. Evlo?
Should we simplify 5 by 3 further?
No need. Absolutely no need. Pratesh, no, absolutely no need. Yes. No need. 50 volt by 6 ohm. 25 by 3 ampere. What's I? I is simply I1 plus I2. One idea. I1 plus I2 is one idea, one of the idea. The other idea may be total current is V total by R total. What's V total? Array V total single V எல்லாம் ஒன்று தான் ஒன்றே ஒன்று தான். That is that 50 தான். அதில் ஒரு சேஞ்சும் கிடையாது. So 50 volt. What is R total? இதை கண்டுபிடிச்சு வச்சிருக்கீங்களே 5. So it's going to be 10 ampere is going to be the total current. This is going to be 10 ampere. Or nothing wrong. I1 plus I2 is I. அதுவும் ஓகே தான். This is I1. This is I2. They join together and give you I. So it's very clearly I1 plus I2 is equal to I. That's also fine. அப்போ போடு இதில் I1 plus I2 substitute பண்ணு. I2
30 by 3 times.
Yes, you will again get 10 ampere. நீங்கள் எப்படி வேணாலும் போடுங்க, உங்கள் சாய்ஸ் தான். This is your choice. Right கண்ணா, புரிஞ்சுதா? So in series combination what is common? In series combination, in series. Current is same or current is common. Let us say current is same, right?
Yes.
Just one second, I am coming back. Yes. So this is, I hope you understand. In series combination current is same, in parallel combination voltage is same. அவ்வளவுதான் simple. இதை வச்சு அப்படியே ஓட்டிட்டு போயிட்டே இருக்க வேண்டியதுதான். சரியா? Right. Shall we go ahead?
Yes, sir.
Add. Now I'll slightly increase the level. $20 ohm parallel. What's the answer? 20 ohm parallel. What's the answer?
10 ohm.
10 ohm. That's right. 20 series? 40. So 100 series?
200. Sir.
3 number of 100 in parallel? 3 number of 100 in parallel?
100.
3 number of 100 ohm in parallel. What's the result? 3 number of
100 by 3, sir.
100 by 3. That's right. So 100. Your answer will become 1 by R equal to 3 by 100, because it's 1 by 100 plus 1 by 100 plus 1 by 100, which is nothing but 3 by 100. So naturally you get resistance in parallel is simply given by reciprocal of this. ohm. This answer 100 by 3 is the answer. Getting it?
Yes, sir.
Yes. So now tell me 5 number of 500 ohm parallel. What's the answer?
100.
100 is
500 by 5. 500 by 5 is nothing but 100. Right? 5 number of 500 in series. What's the answer?
2500.
25. 2500. 2500. 500 plus 500 plus 500. 5 times. Now I'll give a simple question for you. I mean numerical. You should solve and give me complete answer by yourself. Yes, it goes like this. R1. This is 10 ohm, 20 ohm, 20 ohm. 5 ohm. This is just 2 ohm. எல்லாம் கனெக்ட் பண்ணி
Is this both series and parallel?
of course you are right.
Sir, what do we have to find?
Yes, current in each section you have to find. You have to find current in each section. I am giving you here 24 volt battery. What I want is, I want I1, look at here, I want I2, I want I3, I want I, again I want I. ரெண்டு ஒன்று தான், இந்த பக்கம் அந்த பக்கம் ஒன்று தான். Yes, I hope you get the answer. முதல் at least you understand the question, I believe. At least you understand the question, I believe. So I want to call
Sir,
it
how
as
many volts battery?
24 volt. 24 volt. I want to call it as R1. This 10 ohm is called R1. This is called R2. This is called R3, and it goes on. R4, and the last one is R5. Yes, go ahead. I want I1, I2, I3 is my specific interest. Come on. I1, I2 and I3.
Sir, I is equal to 2 ampere.
Yes, sir, 2 ampere.
Is it 2 ampere?
Yes, sir.
Sir, I'm also getting 2 ampere.
Is it 2 ampere, Kanna?
Yes, sir.
All of you got the same answer? All of you got the same answer?
You got 2 amperes, but I'm a bit doubtful.
Yes, we'll discuss. No issues. We'll discuss.
Can we do it now?
Sorry, I will do it. I'll do it now. Now first we want to take 10, 20, 20 parallel.
Sir, I will be sum of I1, I2 and I3.
No need. You can solve the entire resistance. Entire voltage by entire resistance is easy way to calculate I rather. Right?
Okay, sir.
That's of course what you say is right. Nothing wrong in that. Nothing wrong in that. Okay, fine. Come on. But in this here, the best way is calculate the net resistance and then calculate the net current. That's the best way in this case. Otherwise, you will be in trouble. Okay, I'll explain one by one. Let us wait. Now 10, 20, 20 parallel. The conventional way of doing this is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. எவ்வளவு வரும் உனக்கு? R equal to சொல்லுக்கண்ணா. R சொல்லுக்கண்ணா. Come on.
10, sir.
No.
Hi, sir.
You get 5. By solving this, you get 5.
I meant R1 is equal to 10, sir.
Okay. You get 10, right? See, actually today I given YouTube link also along with this, but majorly our students are all attending in our Zoom only, but 1 or 2 students might be attending in the YouTube. Okay, our prime is not YouTube, but just I gave. Okay, fine. Come on, 5 ohm. இது வேற மாதிரி எப்படி புரிஞ்சுக்கலாம்னா ரொம்ப ஈஸியாக புரிஞ்சுக்கலாம். எப்படின்னு கண்டா, லுக் அட் திஸ் இஸ் 10 ஓம். புரிஞ்சுக்கிறதுக்கு ட்ரை பண்ணுங்க. இட் இஸ் ஈஸி டு அண்டர்ஸ்டாண்ட். இட் இஸ் வெரி ஈஸி டு அண்டர்ஸ்டாண்ட். 20, 20, it is 10. By connecting how many number of 20 in parallel you can get 10? Once again I repeat my question. Yes.
2, sir.
Yes, you are right.
Can you repeat the question?
Yes, I want to connect few resistors in parallel. I want to connect how many number of 20 in parallel.
Sir.
How many number of 20 ohm should be connected in parallel to get 10 ampere, 10 ohm is my question.
2, sir.
Sir, 2.
Yes, already just in the beginning of the class I explained you. 2 number of 20 connected in parallel shall give you 10. 3 number of 20 connected in parallel shall give you 20 by 3. 4 number of 20 connected in parallel shall give you 20 by 4, which is 5, which is nothing but 5. But time being, my question for you is, this 10 I want to replace with 20s. How many 20s I should connect in parallel?
Sir, 2, sir.
2 number of 20s. So remove this, put 2 number of 20s. 20, 20. What I mean to say, remove this, put 2 number of 20s. 20, 20. Now how many 20s are there?
4.
20 by 4.
5.
That is the answer here. That's the answer here. Right. So what I mean to say, எல்லா சர்க்யூட்டுக்கும் நம்ம எல்லாத்துக்குமே LCM எடுத்து இப்படி 1 by 1 by போடணும்னு அவசியம் கிடையாது. கொஞ்சம் நல்லா புரிஞ்சுக்கிட்டா you can go by shortcut techniques. Yes. இப்போ சொல்லுக்கண்ணா என்ன இருக்கு சொல்லிக்கலாம். 2 ohm, 5 ohm, 5 ohm. So 2 ohm, 5 ohm, again 5 ohm. 2, இது ஃபுல்லாக சேர்ந்து 5, இது ஒரு 5. All of them are in series and connected to what voltage? 24 volt. What's your current now? Come on, what's your current now? Current is given by 24 volt by, come on,
12.
12, sir.
12.
oh, 2 ampere. So you kids gave me correct answer. So this is 2 ampere. This is nothing but 2 ampere. Right now, very good. YouTube also, Ajay answers 2 ampere. Excellent. Ajay, you are from which school? Ajay, kindly let me know you are from which school, my dear child. Yes, come on. Now this 2 ampere flows through this. What's the potential difference here? யாராவது help பண்ணுங்க பார்க்கலாம். யாராவது help பண்ணுங்க please. What is potential difference here? What is potential difference? இங்க கண்ணா, you are right. 2 ampere, 2 into 2, 4 volt. இங்க எவ்வளவு சொல்லுக்கண்ணா? 2 into 5, 10 volt. இங்கே எவ்வளோ சொல்லுங்கண்ணே
10.
10. 10 plus 10 plus 4.
24.
Done. It's done. Excellent. இப்போ oh, Ajay is from North India somewhere. Okay, excellent. Excellent. Keep it up. Beautiful. So 4 volt, 10 volt, 10 volt. Yeah, I hope you understand. Now this 10 volt is applied here. Done. This 4 volt is applied here. Done. But our interest is here. For this parallel combination, what's the voltage? Come on. For this 10 volt. So the point to be understood is this parallel combination gets 10 volt. That's what is most important. This parallel combination gets 10 volt. Getting it? 10 volt.
Yes, sir.
Now you look at only the parallel combination. Now this was the parallel combination given to you. This was the parallel combination given to you. In the Cholpakla, what was given to you? 10 ohm, 20 ohm, 20 ohm. இப்படி இருக்கு. Now what's the potential difference here? What is the potential difference here? Come on. எவ்வளவு கண்டுபிடிச்சீங்க இப்போ நீங்க? You found just now, you found it?
10 volts.
10 volt.
10 volt.
5.
Now tell me, what is I1? Come on. What's I1? 10 volt by 10 ohm. कितना यार?
1.
1 ampere. I2. 10 volt by
0.5.
20 ohm. 0.5 0.5 ampere. That's right. This is I2. Now I3. Come on, come on. I3 is 10 volt by 20 ohm. How much you get? 0.5 ampere. Getting it?
Yes, sir.
I hope you got it. Yes. Some child Ajay joined from somewhere North India probably. He is doing excellent job. Shall we go ahead, Kana? I hope you understood the question. I know question is I am going to give you one more question like this. Let us see how you solve it and respond me. Shall I give?
Yes, sir.
Shall I clear this? Or shall I clear this, or you want?
Sir.
I can clear this. Good.
Sir,
Yes, Kana. Yes, my dear child.
sir, I understood the numerical method, sir, but I did not understand adding two more resistors. Is it okay if I do it in a numerical method?
Ordinary method, I mean conventional method, you can go, Kana. Absolutely no issue. You can go, right?
Okay, sir.
Please, all of you come back here. All of you may please come here. Come on. R1 equal to 20 ohm. R2 is equal to 5 ohm. You can start. You can start copying it. Is it visible? Yes, it's clearly visible. R3, R4, R5. Right? $30 ohm. R5 is also 30 ohm, but R3 is just 10 ohm. It is just 10 ohm, right? Now I have your 50 volt. Now the question for you are, what is the potential difference between A and B? VAB kitna? What's the potential difference between A and B? Then what's the potential difference between B and C? B and C. Potential difference between B and C. Yes. Then the other questions are I1, I2, I3, I4, I5 and altogether I. Altogether I. I hope my diagram is very clear without any ambiguity. I hope my diagram is very clear.
Yes, sir. Sir, I got the answer.
You got the answer for the entire question, you mean, right?
Yes, sir.
Great. Yes. I will consider copying your answer here. Come on, Kana. I1, I2, I3, I4, I5 and altogether I. Is it okay if I copy your answers here on the board?
One second, sir.
Yes, anyone give me answer? Anyone please give me answer for these questions?
Sir, can I?
Yes, yes, please, please.
Sir, I got potential difference between A and B as 20 ohms and then between B and C as 30 ohms.
20 volt, 20 volt.
Sorry, volts.
Yes, 20 volt, 20 volt. One is 20, other one is?
30.
That's right. 20 volt, 30 volt. So these are the answers. Come on. That's right answer, I believe. What's I1, I2? What is I1, I2?
I got I1 as 1 ampere and I2 as 4 amperes.
I1 is 1 ampere, I2 is 4 ampere, okay, okay. I3, come on. Why you take so much of time? फटाफट I3 சொல்லுக்கண்ணா I3 சொல்லப்பா. What happened, Rishi? Rishi? Ajay, can you post answer?
Sir, 3 ampere.
That's right, 3 ampere. Why you think so much? Come on.
Sir, 1 ampere. 1 ampere.
Finally, I. I value. How much is this?
5 ampere.
Yes, 1 plus 4, 5 ampere, or 3 plus 1 plus 1, or the total resistance, by total voltage, that's also fine. Shall we begin? First, inga aramikkalama. What's R12? Come on, R12. 20 into 5, 20 plus 5. R1 R2 by R1 plus R2. Or you go for 1 by R1 plus 1 by R2, either way. What's your answer? What's your answer?
Sir, can you zoom out a bit?
Yes, I forgot, Kanna. You are right. Yes.
Thank you.
Is it right? It's R12. Then when you consider here, it's again 1 by R345, 1 by 10, 1 by 30 plus 1 by 30, R345 is going to be 6 ohms simply. R12 is simply 4 ohm. So it's very clear 4, 6 are in series. Then what's the total resistance? 10 ohm. Therefore, the total resistance R 1, 2, 3, 4, 5 put together is 4 plus 6 ohm, which is nothing but 10 ohm. Which is nothing but 10 ohm. Right. Then what's the total current? Total voltage by total resistance, which is nothing but 5 ampere, is the total current. Is the total current. Is it fine, Kanna? Is it fine?
Yes, sir.
Yes, sir.
Should I explain more about it? Should I explain more about this particular problem, or you are convinced with the answers?
Sir, it's okay, sir.
Fine. Good. Those kids on YouTube, just put your answer. Come on. Just you let me know whether you understand this. There are 1 or 2 kids understand watching on YouTube. Please tell me. Put a thumbs up. Let me know that you are there.
Sir, I understood finding R equal to 4 and R equal to 6 after that picture.
After that, you could not clearly understand, right?
Yeah.
Sure, I will explain. Just don't worry. I will explain. Yes. So, after this is 4 and this is 6, the circuit gets a simplified format like this. This altogether will be replaced with 4 ohm. This altogether will be replaced with 6 ohm. However, your battery remains the same. What is that? 50 volt. Now what's the current through this? Now look at 4 plus 6, very clear. We need not write one more formula for that. 6 plus 4 core formula we do not require. Then what's current through this? What is current through this? Current through this given by 50 volt by 4 plus 6, 10 ohm, 5 ampere. So 5 ampere current goes. So this is 5 ampere current. That's what is this 5 ampere current, right? Then what's the potential difference here? What's the potential difference here? 5 IR. IR. I is 5, R is 4. So this is 20 volt. Okay, what's the potential difference? 5 into 6. IR 30 volt. Compulsory 20 plus 30 50. Got balanced. Now the question arises. This 20 will be posted here. This 30 will be posted here. Now this 20 volt is common for these two fellows. Therefore you get this current.
Yes, sir. That
This 30 volt is common for these three fellows. Therefore you get this current. Now you understand?
Yes, sir.
Excellent, Kanna. That's nice. That's nice. Vijay KR. Yes, I explained, Kanna. Vijay KR. Now it's okay.
Sir, can you repeat? Can you repeat that? How that 4 ohm and 6 ohm get simplified again?
Yes, Kanna. I will explain once again. 4 and 6, how they got simplified? It's so simple. Look at here. It is 1 by R equal to 1 by R1 plus 1 by R2. This is what you want to know, no? How you got this 4? That's what you want to know, right? Am I right?
Yes, sir.
Yes. 1 by R12 is equal to 1 by R equal to 1 by R1 plus 1 by R2. Solve this. 20 is the LCM. 1 plus 4 is 1 by R12. You get R12 is equal to, come on, 4 ohm. Do you get? Understand? LCM புரியுதா? புரிஞ்சுதா? Yes or no, my dear child?
Yes, sir, I have understood.
You understood now. Yes, yes. Shall I take you to next spot then? Shall I take you to next spot then? Next spot poilama?
Yes, sir.
Yes. Now we are going to trying to understand an important part called applications of heating effect of electric current. Applications. Even before application, first we should understand that heating effect. First we should understand today. Yes, we shall go for it. Come on, heating effects of
Sir, your voice is closer. I was not able to hear.
Oh, is it common for everyone? Is it common for everyone? Come on, Kanna.
Your voice is clear to me.
Clear only.
Yes.
Actually, when the internet issue comes, the first voice will be down and then only video will be down. That's how the Zoom is working. So please check. Maybe sometimes my internet also goes down, but I think currently it's okay, I think. Yes, heating effects of current. Let us discuss today heating effects of current. Shall we go ahead, Kanna? Shall I start?
Yes, sir.
This is a resistor R. What resistor it is? It is a metallic resistor R. It's a metallic resistor R. Now what you do? You connect it to a battery of potential difference V. You connect it to a battery of potential difference V, right? What happens? Current flows through this. Now the question arises, why current flows? What is the agency for current, for agency which makes the current to flow? What is the agency which makes the current to flow? Come on, Yaroswal Kanna.
Potential difference.
Potential difference. Excellent, excellent. potential difference which maintains a potential difference like this, like a waterfall. In the waterfalls, the water falls from higher potential to lower potential. In the same way now, this is at higher potential positive, this is at lower potential negative. Current naturally, I mean the charge, positive charge flows from higher potential to lower potential. Now the simple definition, go back to very first definition.
Doubt, sir.
Yes, Anirudh, please.
Sir, conventionally we say that positive has higher potential and negative has lower potential. Sir.
Yes, you are right. You are 100% right. Universally, in the field of science, we accept that positive is at higher potential, negative is at lower potential. You are right.
Yes, sir.
Yes. Now what happens? Let us go back to the very first definition that NCERT textbook or in our notes. In this particular lesson, current electricity, when we began, we must have given you something called potential or potential difference. What is potential difference between any 2 points in an electrical circuit carrying current is defined as, come on, fill the sentence.
Work done to move a unit charge.
Beautiful. Work done per unit charge in moving from one point into another point. Excellent, Aparna. That's right. Work done. Therefore, potential difference between any 2 points is simply defined as work done per.
Sir, I have a doubt.
Yes, Kanna, please.
Sir, my teacher gave a definition as it is the work done to bring a unit positive charge from infinity to a specific point.
Perfect, perfect.
So what is that infinity?
No, that's perfect. That's perfect definition, no doubt. So all those depends on whether you define potential at a point or you define potential difference between 2 points. Here it is potential difference between 2 points, this point and this point, I mean negative and positive. இதெல்லாம் எடுத்துட்டு, this is my room here. In this room, this is a point. Let us assume this is a point. In the point, what is potential? Then you bring a charge from infinity to that point. Once again, I tell you, potential at single point is different. Potential difference between 2 points is different. Getting it? If you want potential at a single point, please check your notes, whatever you have. Potential at a single point is defined as work done in bringing unit positive charge from infinity to that point. Okay? What is potential difference? Adeda work done per unit charge in moving from one point into another point. That's all. Once again I repeat, potential at a given point, single point, is defined as work done per unit charge in bringing it from infinity to that point. Potential difference between 2 points is defined as work done in moving unit positive charge from one point to other point. Is it clear? Rishi,
Yes, sir.
you got it?
Yes.
Yes. Here we talk about potential difference. So V is equal to W by Q. Getting it, Kanna? V is equal to W by Q. Yes. But today our topic is more interested in heating. Heat is energy. Energy is nothing but work. இதெல்லாம் நம்ம 9th standard படிச்சிருக்கோம். In 9th standard itself we learned. Okay? Heat is a type of energy. Any energy is supposed to be work done. Any energy in the world, in the universe, is supposed to be work done. Is supposed to be work done. அப்போ இதை பற்றி தான் நம்ம பேசிட்டு இருக்கோம். We are talking about this. Come on, tell me. Then what's work done? Come on. What's work done?
VQ, sir.
Equation number 1, where Q is flow of charge, V is potential difference. Now the question arises, okay sir, W everything is fine. Who did this work? Whether Ravi did or you did or battery did or current did. Who did this work? Yaar senja and the valley. Who did this work? Come on. Who
Sir, the
did?
resistor.
By resistance, not at all. Not at all.
Battery.
Sir, the battery, sir.
Battery. See, when they do use of battery, the battery loses its energy, finally it dries up. We throw it and we'll take another battery. We purchase another battery or we replace another battery, right?
What about the wires, sir?
Wires cannot do any work for you. Bulb cannot do
The
any work.
wires are only joining.
Wires are just carriers. They're just carriers. Say, you open the tap in your kitchen, you get water. Doesn't mean that the pipe supply water for you. No. Pipe is a carrier. Like wire is a carrier. Wire is just a carrier. புரியுதுல? டேங்க்ல தண்ணி இருந்தா தான் வரும். அதே மாதிரி if there is energy stored in the battery, you get current. Otherwise you will not get current. Getting the point? Getting the point? Yes, yes, good. Any other doubt?
Awesome.
Good. Even the children on YouTube can ask me if you have doubt. Please put it on chat box. Excellent, Kanna. Flow of charge. This is potential difference. This is potential difference. But we are now interested in calculating work done. Today we are interested in calculating work done. Polama.
Sir, can we say W is equal to IRQ?
W is equal to, sorry, yes, we are going to do that. We are going to do that. You are right. Now continue this. Continue this. W is equal to work done equal to V times. What is Q? When a steady current flows I is simply given by charge by time. Then what is charge from this? Come on, cross multiply. What is charge from this? Come on.
IT.
Current into time.
Current into time. Therefore, heat equal to energy equal to work equal to VIT. Once again, work done by battery in maintaining, come on, in maintaining current, come on, in maintaining current. W is equal to cholukana VIT. This work done is what is called heat, VIT. Now let me explain you clearly. What is this resistor I am talking about? I am talking about resistor. Have you ever seen resistor?
Oh,
Have you ever seen resistor? Pratyush?
not sure, sir.
Not sure. Anyone? My dear kids on YouTube, come on, put on a chat box. Have you ever seen something called resistor? Have you ever seen?
Open up CPU, VCA.
Oh, when you say open your CPU, often you see something. Excellent, Kana. You have seen resistors. Come on.
Fans, regulators.
Yes, fan regulators. Excellent. Even on YouTube, I got one child has answered me. Vijaya has answered me. Fan. Yes. Anything other than that?
Bulbs.
Beautiful, Kanna. That's what I was waiting for. Look at this bulb. This is an excellent example for resistor. It consists of tungsten, whose melting point is roughly more than 3000 degrees Celsius. The melting point of tungsten is more than 3300 or something like that, approximately. Yes, that's the melting point. Okay. This is an excellent resistor. It's a very good example for resistor, metallic resistor. It's a very good example for metallic resistor. Appo, in the earth, how can you visualize this as if some bulb is connected here? You can visualize like this, nothing wrong. Some bulb is connected there. Getting the point, right?
So is rheostat like resistors? Sir?
Yeah, okay, fine, no problem. Rheostat like resistor will not get heat up fast because they permit less current. Therefore, they will work as a resistor for you, but they will not give you light. But these people, like tungsten like materials, they permit huge current because the resistance is less. It is designed in such a way the resistance is less. Therefore, when huge current flows, there is a lot of heating effect. Due to the heating effect, it starts glowing by itself. You are getting the point?
Sir, but you can adjust the resistance in the rheostat.
Of course, you can adjust the resistance here, rheostat. That's what. Both are resistances only. The design and the purpose are different. Here the purpose is, in the case of bulb, the purpose is to convert current into energy. I mean light energy, sorry. In the case of rheostat, our objective is just to control the current, nothing else. Just to control the current.
Used only in laboratory space.
Just to even nama veetla fan regulator irukke. Yes, someone was telling me, even Vijaya has answered me on this YouTube. Fan regulator everybody speed vekkirammala 1 2 3 tip. Enadhu idu? Resistance. More the resistance, less the speed. Less the resistance, more the speed. Getting it?
Yes, sir.
Yes, come on here. Heat is equal to V into I into T. Right? It is what is heat. This is what is heating effect of current. So you go, finally we got answer for heat. Sariya kanna? I hope you understand.
Yes.
Yes. Come on, kuch copy pannilama. Shall we copy it? I will dictate few lines. No doubt. Please first copy பண்ணி முடிச்சிடுங்க. I think next class, next Friday, we are going to complete this. I want to discuss with you. Shall we have class on Sunday morning 7 to 8? On the other day we discussed, I remember. I think Sunday morning 7 to 8 is.
I have another class from probably, usually it's 5:30 in the morning. Sunday they'll leave a bit free and they'll keep at 6:30.
So, 7 o'clock okay, Dikshita? 7 o'clock okay?
Sir, you'll be
class
up
be
to at
recorded?
least 8.
Sorry.
Sir, will the Sunday class be recorded, sir?
Of course, compulsory. It will be recorded, no doubt. Dikshita, you are saying, Anirudh, you have some concern, right? Small time, part of time you may miss it, right?
Sir, from Monday my exam starts. Sir.
No, I am telling you just permanently, can we have the classes on Sundays? That's what I am asking you. Is
Sir,
it?
it's okay for me.
I think it's okay for everyone. I think Dikshita has got some issue. Come on, Kanna, what's your issue, please?
Sir, the class will be at least up to 9 or maybe 8:30.
Oh, you want to have more longer class, you mean, right?
My another class, so my maths tuition.
That is, what's the range of that class?
Sunday probably it will be from 6:30 to 9 or something.
Oh my God. Oh. Okay, please check that, Kanna. You please check that and contact me on WhatsApp. I hope you have my number. All of you, my dear kids, you have my number now.
Yes, sir.
Yes, sir.
Yes, 7338 96332. Ravi, right? You call me for any help whatsoever. Fees does not matter. Fees is just secondary. We want to help the children. That's all, right? Fees is just secondary. Yes.
Can we have it 9 o'clock?
Sorry, Kanna. Dikshita.
Can we have it 9 o'clock on Sunday morning?
Sorry, Kanna. Actually, the fact from my side is why there is a small adjustment I am making now. I am trying to make now. The reason is now from last week I started allotting a lot of classes for 11th and 12th IIT batches. Nowadays I am teaching them 6 to 8 hours per week. Yearly it was just 3 hours per week. That's my usual pattern. Usually now only the children have learned something. For 11th students now one textbook is over. Now they got some base in the physics. They can do a lot of problems now. But I have to concentrate more on them. Therefore, nowadays I am offering them 6 to 8 hours. Sunday morning, for your information, 8:15 to 10:15 is blocked for 11th standard, and then 10:30 to 12:30 is blocked for 12th standard. My time. I have to teach them.
Sir, can we have it afternoon like 1, 2, 3, anything?
I will check, Kanna. I will check it. You also please check with your maths teacher. If you can be free by 7 o'clock, please check and get back to me.
In the tuition, more than 100 people are there, so everyone will be
It's online.
predicting.
It's online class or offline class, Kanna?
Online, sir.
Online. Okay. Okay, Kanna, we'll check that. Don't worry. We'll check that. Don't worry. We'll see that. You know, from our side, you know, our whatever we do, you will get 100% recording. You will get. All the time you will get 100% recording. You get. You need not. Anyway, you check it and get back to me. No problem. Shall we write few line about it? Just 1 or 2 line about it. Shall we start writing, Kanna?
Yes.
Yes, sir.
Yes. Please start writing here. Let V be the potential difference applied across the resistor R. Let V be the potential difference applied across the resistor R. Let V be the potential difference applied across the resistor R. Full stop. Work done by the battery, just 2 lines, not more than that. work done by the battery, work done by the battery, work done by the battery for the flow of charge q, work done by the battery for the flow of charge q, work done by the battery for the flow of charge q, for the flow of charge q, work done by the battery for the flow of charge q is given by, come on, W is equal to, come on, W is equal to work done by the battery. What you have to understand is this work is done by the battery. That's what I wish you should understand, right? You have to understand. Work done by the battery for the flow of charge q, W is given by, come on, W is, please write, W is equal to, சொல்லுக்கண்ணா VQ, V into Q. அதுக்கப்புறம் அப்படியே காப்பி பண்ணிக்கோங்க. Now I need not dictate anything more than this. You can copy the rest as it is, or if you already copied, fine. If you already copied, fine. If you have any issue with the link, getting link or YouTube link or whatever may be, you text on my number. This is my number. You will get